So if I say Alessio, it's now on the internet forever. You got that? We're on 65. We're prepping for our polynomial rational exam. Number 65 is called a rational equation. And if you don't listen to me on the video or talk over my video, you will be on the world forever. Someone's going to listen that someone said something.
Hello.
There you go. For real. This is going on today. The World Wide Web. Anywhere in the world can access this video and hear you. So, number 65 is called a rational equation. To solve a rational equation, we're going to start with two things. The first thing we're going to recognize is the denominators need to be the same, and there's a restriction for the answer. And the restriction comes from the denominator. What makes the bottom 0? What x value? So x cannot equal 1. Why not? You plug in 1, it's a 0 on the bottom, it's undefined. Also, can you see how I quickly changed 2 so that we have common denominators? I'll wait for a moment. You try the next step. And if you're on video, you can always fast forward. Now, I'm going to write down only the numerators. What's the first numerator? The next one, negative 8x. And the last one is 2x minus Madagascar. All right, here we go. You ready to solve for x? How do I get the x's together? What should I do? Bring it. I'm not bring it. I always bring it. I want to add, subtract, multiply, or divide. What do I do to bring the x's together? Let's do it. You could either subtract 2 or add 8. Yes? So I'll add 8. I like keeping things positive because I'm a positive person. So 2 plus 8 is 10. What can I do with the negative 2 and the 8? What is 8 plus 2? Divide? What does x equal? X equals 1. The symbol for no solution is a 0 with a line through it. That is not a 0. That means there's no solution. To those that love drawing their zeros that way, stop it. And when you do this symbol, use it for when it's no solution. Yes? Number 60. Let's get going. Are you awake yet and ready? It's Monday morning, no exam today. So we get to prep and get our brain going, right? A, can you tell me what x cannot be? Look at the first denominator. 0. Look at the next one. 5. That cannot be a long process. The first denominator, 0. The next one, 5. Now I need to make the denominators the same. So what does the first denominator need that the other two are and have? X minus top and the next one. What does x minus 5 need so they can be exactly the same as the other one? Top and then of course x minus 5 again. What do we need? Top and bottom. X. Alright, are the denominators the same now? You know in math, you get what you put into it. If you're going to prep and study and come Tuesday after school and care about this, then your exam's going to show. Only the numerators. So I'm going to write down 6x subtract 30. Do you know where that came from? Then I'm going to write down 8x. Then I'm going to write down 2x. This is a linear equation. The degree of it is 1 that you don't even see. I need to combine like terms and get x by itself. Can you do that? Can you combine like terms and get x by itself? So 6 plus 8 is 14x. Next. Choices. I'm going to subtract 14x. That's my choice. So when I subtract 14x, I'm going to continue over here. Negative 30 is equal to negative 12x. Divide by negative 12. Does that go in evenly? how can I reduce it down? Is that a positive or negative number? Correct, because a negative divided by a negative. What's the largest number that goes into both? So that would be what? Or you could write the answer as, what should I check at the end? Is that a restricted answer? So, that's it. There's you're done. Number 67. Number 67 is a rational equation. What can x not be? What are the restrictions from the denominator? Both positive and both of them would make a 0 on the bottom. Now I need to make the denominators the same. So the first denominator needs x subtract 2, top and bottom. The next one needs x plus 2, top and bottom. And the last one needs an x subtract 2, top and bottom. Can you make the denominators the same? Once the denominators are the same, then I write down only the numerators. I see 6x subtract 6. Do you see it? Yes. I want you to think of 5 as negative 5. Can you put them together? So that's negative 5x and negative 10. Negative 5 and distribute it. See it? Negative 5 and distribute. Yes?
Wouldn't it be 3x on 5? Yeah. 6x.
Where?
At the beginning, 6x.
3 times x is? I was just testing you. 3x. How about this part? How about the negative 10? The part I was like too focused on that you wouldn't see. Do you see the negative 10?
Yes.
How about the right side? 2x subtract 4. Next, it's linear. Can you combine like terms? Go for it. Make sure you check on, make sure I don't make a silly mistake. How can sometimes you guys are so good at my mistakes, but when you make a mistake, you're like all like blind about it. All right, just check. Negative 2x minus 16.
Yeah.
Combine negative 2x and 2x. What can I do? Add 2x. That would be how many x's? How about negative 4 and negative 16? Be careful. What do you get? Negative 12. And then what would the last step be? What's wrong, Joseph? Which one are we looking at? This is a negative 5 times 2. That subtract sign belongs to both. I'm glad you're paying attention, though. Is x equals negative 3? Is that an extraneous solution or a good one? So you check, right, at the end to make sure. Turn the page. Hey, story time. Nothing like a math story before bedtime. Right to sleep. All right, you then me. Again, if it's a video, you can fast forward. I expect you to annotate this. Go. You only learn by doing it, not by waiting and copying. What type of problem is this? It's called a work, right? You have a rate? So there's one number I circled. That is what? What does that represent? Does it represent the experienced auditor, the new auditor, or together? Together is by itself. And to find the rate, you do the reciprocal. So the rate is every hour 1/16th of the job is being done. On the other side is individual. Do I know the experienced or the new auditor? No, right? So there's two ways to think of this, but I think the best way to think of it is that if the experienced auditor is going at this rate, that means the new one goes twice as slow. See, the denominator tells you how long it would take, right? And if the experienced one takes X, then the new one must take twice as long. Do you see how I flipped that around in the story? So X is the experienced, 2X is the new auditor because it takes twice as long. All right, how do I solve this? Common. I need to make the X into what number here? 16. Top and bottom. 2, it needs an 8. And then the last one needs an. So we have 16 plus 8 equals X. What's a good sentence? What would happen if the question asked for the new auditor? What would that answer be? 48 hours. See, twice as long, right? All right, read number 69. So I'm going to give you a moment. Set it up. Then I'll set it up. So we have AJ, we have the apprentice. So you take how long it takes to do the job and you do the reciprocal for the rate, and then my unknown is together. Do we do that? So to make common denominators, we need 2x, just x, and 30. So that leaves me with 2x times 1, 1 times x, equals 30. Now it starts to get easier. And then once you have your answer, how long would it take them working together? It would take
10 hours.
To do what? To overhaul a boat's diesel engine together. Right? It would take 10 hours to overhaul a boat's diesel engine together, right? Or working together. Number 70. right, did you annotate it? Do you know what 32 represents? What does it represent? How long Tracy would do it by herself, right? Or himself. Herself. So, what's the rate? How about 17?
Together.
So that's by itself, right? And the reciprocal is the rate. And then, my unknown is the... Oh, that was on the video right there. So then, I know, right? Bad word. Go back 1555. Evidence. So, I need common denominators. So this needs a 17 and x. This needs 17 and 32. I'll do that in a second. That's not impossible. Then the last one needs a 32 and x. So I have 17x. On the side, I'm going to go 32 times 17. 14, carry the 1, 22, 2, 3. Oh man, that didn't take that long. 544. Next, combine like terms. What's 32 take away 17? And then what's the last step is to divide, right? So if I want to approximate that answer, how many 15s are in 544? I know, just do the math. It's 3, that's 45. Subtract and it's 9. 15 and a 94. 6, right? That's 90. And the remainder is 4. So this answer is approximately 36 and 4 over 15. So how long would it take the trainee working by herself? And the answer is it would take a little longer than 36 hours to wallpaper 4 rooms who's doing this work? The trainee. It would take the trainee. So it would take the trainee a little longer than 36 hours to wallpaper 4 rooms. Number 17. Sue can sew, say that enough times. Sue can sew a pre-cut dress in 3 hours. Helen can sew the same dress in 2 hours. If they work together, how long would it take them? So if they work together, how long would it take them to complete sewing the dress? Give your answer to round it to 1 decimal place. Let's start this. Sue can sew, so the rate is 1/3. Helen, she's not as lazy, 2, and then together. Yay? What's the common denominator? And x. So make them all 6x. So I get 2x plus 1x equals, what is it?
2x plus 3x equals 6.
2x plus, oh, it should be a 3x on top. 2x plus 3x equals 6. That would mean 5x equals 6, which means x equals 6 over 5. 5 goes into 6 once, and the remainder is 1/5. Any idea what 1/5 is as a decimal? It is 1.2. Joseph, good job. So, like, right, like 5 into 10? So the question is, how long would it take them working together to sew the dress? So it would take 1.2 hours working together to sew the dress. Turn the page. Next story. What do you think the next story is going to be about? Same type of story. 73, it changes. So 72. 2 pumps can fill a water tank in 45 minutes when they work together. Alone, the second pump takes 3 times longer than the first. How long does it take the first pump alone to fill the tank? What does 45 represent? Together. So what rate together are they doing? 1 over 45. So, again, we have to flip this around in the denominator. Which pump is working faster? The first one? So, I'm going to let the first pump be X, and the second pump is 3 times as slow, or 3 times longer, right, to do the work? So when I solve for X, that's not the end. I have to triple that answer to get the one I'm looking for. X is going to be the fast pump, but times 3 will give me the slow pump. Okay, what's the common denominator? 45. How many times does 3 go into 45? Top and bottom. The last one needs an X. Did I do that okay? So the numerator is 45, then is 15, and then it's equal to X. Can you add that? So the fast pump takes how long? 60 minutes. So the slow one must take how long? 180. So how long does it take the first pump working alone? So the second pump takes 3 times as long. So the first pump actually is what number? The second pump is 180, being a good reader, right? So it's really 60 is what we're looking for. So it would take the first pump 60 minutes or an hour to fill a water tank. All right, now we're changing stories. Read 73. The first stories were work. Now it's a different type of math story. So read it. So, break down the story. Do you realize this story has to do with distance, rate, and time? What formula do we use for distance, rate, and time? And in this case, we do have 2 people. Sometimes it's the same person, just going there and back. Here we have Rob and Carl. So, what do we know that's easy is that Rob travels 124 miles. In the same time, Carl travels 108. And it says Rob's trip uses more. He averages 4 miles per hour more. So who's going faster? Rob or Carl? So however fast Carl is going, Rob is going 4 faster, yes? And then what do I know about the time? It's the same. I don't know what it is, but it's the same. So we'll just call that y. I don't know what it is, but it's the same time. So one equation is 124 equals x plus 4 times y. The other is 108 equals x times y. Do you see we have 2 equations and 2 unknowns? To solve this, I'm going to take the top equation. I'm going to distribute the y. That's x times y and 4y. And then the denominator I'm going to keep the same. One of the ways we can solve a system is using elimination. Do you know how I'm going to eliminate something here? Is I'm going to subtract the 2 equations together. What happens when I subtract them? So 124 take away 108 is... And what happens to the xy's? They eliminate. And then 4y take away nothing is just 4y. So what does y equal? So what did we just find? How many hours did they travel? 4. The question is, what is Rob's average speed? So Rob's average speed, right, has to do with x. So in other words, I'm going to take the answer. I can go to either one, right? So if I can go to either one, I'll go to this bottom one. Where there's a y, what number am I going to put in? 4. And then I'm going to divide to get x by itself. 4 goes into 108. I don't know, 2. How many times? I got 27. You had 27? So how fast was Carl traveling? 27 miles per hour. So then how fast was Rob traveling then? So Rob was traveling faster, right? So how fast was Rob traveling? So we write that down. Rob was traveling at an average speed of 31 miles per hour. All right, let's go to the next story. 2 trains leave a train station at the same time. One travels east at 10 miles per hour. The other train travels west at 12 miles per hour. In how many hours will the 2 trains be 44 miles apart? If this is the train station, when one is traveling east, they're going this way. And when one's traveling west, they're going which way? So the one that's going east compared to the one that's going west. The one that's going east, how fast are they going? And I don't know how much time has gone by, right? That is the speed and the time, yes? The west, how fast? And again, I don't know how much time, but I know the time is the same. And then altogether, this distance is how many miles? So to put an equation together, if you went 12x plus 10x, that would equal 44. Both trains going separately. So together, when I add them together, it needs to equal 44. So 22, divide by 22, and the answer is... So in how many hours will they be 44 miles apart? And the answer is in 2 hours. The trains will be 44 miles apart. Number 75. Ken and Kara are 35 miles apart on a calm lake paddling towards each other. Ken paddles at 5 miles per hour. Kara paddles at 8 miles per hour. How long will it take them to meet? So that's Ken and Kara canoeing towards each other. I know. I'm not an art teacher, but I do know I like to see your canoe and who's paddling in your canoe. Do you know what a canoe is? It's a little boat, right? A little boat. No motor. You have these big wooden things in the water, right? Pushes it along. All right. How many miles apart are they? So what do I know about Ken? How fast is he going? Do I know how much time? No. How about the other one? How fast? 8. Do I know how much time? So those are my unknowns, right? The rate times the time. But if I add them together, what must they equal?
35 minutes.
So 5x plus 8x equals 35. Now, 13 does not go into 35 evenly, but pretty darn close. Because 36, right? So it would take almost 2 hours for them to meet. Hey,
That should be a 2.
which one?
For x equals 1, 12 over 13, there should be 2 something.
2. No. Because 13 doesn't go in there twice. Because 13 and 13 is 36. Right? Or am I wrong? 26.
26.
I'm all off. 26. And the remainder would be what?
10 over, right? 10 over
26. 35 take away 26 is 9 over 13, right? So it would take 2 hours. Like 2 and 9/13. I'll just write it like that. More than 2.5 hours for them to meet. Thank you. Not 36. 26. And the remainder is 9. Good job. Turn the page. All right. Only 3 stories left. What story haven't we talked about? Mixon, 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 Mixon. Different than Nixon. Mixon. Nixon was the president. Mixon is the story. Number 76. You guys in U.S. history, right? 76. Read it. Let's go. The manager of a coffee shop has one type of coffee that sells for $8. Another one sells for 13. The manager wishes to mix 100 pounds of the $13 to get a mixture that will sell for $12. How many pounds of the $8 should be used? Let's structure it. How do I start a mixing problem? Is what is being mixed? You have a $8 coffee, right? That's being mixed with a $13 per pound coffee. And then you have, at the end, you have the mix. In this question, I care about the quantity. How much do I have of each type? In this question, I don't have a percent. Instead, I have money. So in this question, I don't have percent. Instead, I have money. Make it simple. So how much do I have of the 8-pound coffee? I don't know. That is my unknown, isn't it? How many pounds of the $8 coffee? Yes? Don't know. How much does the $8 coffee cost? $8. Make it simple. How many pounds do I have of the $13 one? 100. How much does it cost? 13. Here's the hook. How much do you have in the mix? And then how much will that cost? 12. Can you set up the equation now? So 8x plus, what's 13 times 100? 1300? And then multiply this together and you get 12x and 1200. Yes? Solve it. Can you combine like terms? What would happen if I 8x and 12x? How would you bring them together? 12 take away 8? How about 1300 and 1200? And what do you get? Do you think it goes in evenly? How many times does 4 go into 100? The question is, how many pounds of the $8 should you have? And the answer is 25 pounds. You need 25 pounds of the $8 coffee. Number 77. Do you know that you have permission to print this out again from my website, blank, and do it over again if you needed to because it's going too fast or whatever? 77. A chemist needs 100 milliliters of a 60% solution, but only 40% and 90% solutions are available. Find how many milliliters of each that should be mixed to get the desired solution. You ready? Here we go. Well, how do I start it? How do I start it? What is being mixed? So we're mixing a 40% with a 90% to get a, is that right? A 40 is being mixed with a 90 to get a, in this question again, I care about quantity, but this time it's not money, it's percent. So why not fill in the easy part? 40, 90, and 60, because we're going to have to think about the other part. Where does the 100 go? 100 milliliters. That's the end amount, right? Do I know how many? Do I know how many, right? Both of them are unknown. So I'm going to write down 40x and 90y equals, what happens if I multiply them together? 6 and how many zeros? Yes? Is that too many unknowns? Yep. So on the side, can I write a secondary equation? So the secondary equation is, if I mix them together, how much do I get? If I take them both, together they add up to what? So then what would y equal? 100 minus what? Wouldn't y equal 100 minus x? Why do I do that? So I can come back here, and where there's a y, what would I put in? Do I now have one unknown? Can you now solve it with one unknown? Yes. Do you see how I used the secondary equation? Went back in, now I have one equation, one unknown. That's 40x. That's 9,000 minus 90x equals 6,000. Combine like terms. 40 take away 90. 6,000 take away 9,000. Be careful of the signs, right? They're both negative. So when you divide it and they're both negative, it will actually end up being a positive answer. Does that go in evenly? A negative divided by a negative? How many times? Careful. $60. And if x is 60, guess what y must equal? So the question is, how many milliliters do you need of both? You need 60 milliliters of the 40%. And 60%, right? No, what did I do? You need 60 milliliters of the 40% and 40 milliliters of the kind of flippity flip, right? 40 milliliters of the 90%. So X is the 40 and Y is the 90. So you need 60 of one and 40 of the other. Last story. Number 78. Are you ready? You might think, I need this again. You're going too fast. And the good news is today it'll be uploaded. You can see it again. And then again and again and again. I can't go to sleep. It's 1 in the morning. Watch the video. Go to sleep. Right? Number 78. Here we go. Hey, the radiator. Do you know that's in your car, a radiator? What do you think a radiator does? Hey, right, a radiator cools the engine, right? You know, when engine runs hot, right? When it's running, fire, heat, hot. The radiator keeps the engine from overheating. Good job. So, you know the classic when there's steam coming out of the hood and the hood goes up and they take their hanky out and open up the thing and, it's hot. You know that scene on the movie? That's the radiator. All right, here we go. The radiator in a certain car contains what? 50 what? Liters of 40% antifreeze. So the radiator also in cold places could keep it from freezing. So in one it would be overheating and the other it would be so cold. Imagine if you have water in your radiator and the temperature is below zero, what would the water in the radiator be? Ice, right? That would be no good, right? Can't have ice in there to start your car. So antifreeze keeps it so there's no ice in your engine, or the other way is it doesn't overheat. Yay. All right, the radiator contains 50 liters of 20% antifreeze. How many liters of this solution must be drained and replaced with what? Antifreeze to get the desired strength. All right, what are we starting with? What are we starting with? Right? So, if I think of this, is that what's in the car right now, right? We're going to drain something, right? And then you have the end amount, right, after you drain it. So, the things I care about, again, is the quantity and the percent. So how much do I have right now in the car? 50 liters. And what's the percent? The end, what do I need? The end, I still need 50, right? And we need to have what percent antifreeze at the end? sorry, the radiator now contains 50 liters with how many? 20, but the end amount needs to be 50 with 40%, right? The end needs to be 40 with 50 with 40, and the car right now is 50 with 20. So let's get a sense here. And then you're mixing it with antifreeze, right? That is what? 100% to get that mix. So let's work this way. You ready? Let's let this be the unknown. And let this be the unknown. And see where this gets us. Because that's a 20, right? I have a 20%. I'm mixing with 100%. I want the end amount to be 40. Even though you think you know how much, this will be how much I'm going to drain. So if I went 20x plus 100y equals 2,000, 20 and 2 zeros, right? I know that when I mix it together, it has to mix up to what number? They have to together be 50. So when I subtract x, y equals 50 minus x. So I have 20x, I have 5,000 minus 100x. Combine like terms, and I get negative 80. Subtract 5,000, it's negative 3,000. So when I divide, I'm going negative 3,000 divided by negative 80. That means the same as how many 8s are in 300? 3, right? So that's 24. Does 8 go into 60? So this number would be 7. And then 5. So 7.5. That means that y would have to equal, if I go 50 subtract 7.5, that would be 42.5. Now, the question is, in order to get what I need the 7.5 of what's there to be mixed with 42.5, because I got to double its strength, right? But the question is, how much should you drain? Well, what did you start with? 50. And if you have 7.5 at the end, 50 subtract 7.5 takes us back here again. You have to drain 42.5 and then put in 100% antifreeze to get that concentration. You'll probably have to watch the video again. Or I hope I don't write this question on the exam. All right, so there we go. There's last part of your test prep, right? Mr. G Math, over, out.